Hello, Algebra 2. Welcome to your spiral review for Spiral 9. First off, we're going to take a look at finding the zeros of an equation that is set up in vertex form. First thing I definitely want to do is make this 0 is equal to negative 3 times the quantity x minus 2 squared plus 15. The strategy here is to get the weird thing, the squared part, by itself. If I minus 15 to both sides, we end up with negative 15 is equal to negative 3 x minus 2 squared. Dividing by negative 3 to both sides, of course we have to use both sides, gives us positive 5 is equal to the quantity x minus 2 squared. Now when I go to take the square root, you might think to yourself, oh, Mr. Carlson, that's the worst. It doesn't come out evenly. And what we end up with is a plus square root of 5 is equal to x minus 2, and a minus square root of 5 is equal to x minus 2. To finish this off, all we have to do is add 2 to both sides. And one of the really nice things about this is when you do this, you don't actually have to do the calculation. Because we end up with, and excuse my organization here, but this top value would give us x is equal to 2 plus the square root of 5, and the bottom calculation would give us x equals 2 minus the square root of 5. So we don't actually have to come to any decimal value or any other form of that than the answer. Jumping down to number 4, here we've definitely got some factoring going on. I'm going to go with a times c is equal to 24. We've got a b value of negative 11. Things that multiply to 24 and add up to negative 11 are going to be negative 8 and negative 3. When we set this up, we've got 0, of course, because we're finding zeros, 6x squared minus 8x minus 3x, and then plus 4. From the first two, I can take out a 2x, and I'm left with 3x minus 4. From the second two, nothing can be divided there, so let's take out a minus 1 to get rid of that negative, and we're going to have a 3x minus 4. Okay, in both of these I can take a 3x minus 4 out. So we get 0 is equal to 3x minus 4 multiplied by 2x minus 1. That's going to give me 3x minus 4 is equal to 0, or x is equal to 4/3. And 2x minus 1 is equal to 0, which means that x is equal to a half. Looking on to the next one, we got all kinds of stuff going on. I've got to write in factored form, find the zeros, find the vertex, find the y-intercept, and sketch a graph. I might do this out of order today because I kind of feel like being reckless. So I'm going to find the y-intercept first because I know that is just going to be 8. And I'm even going to graph that right now. 8. There, done. Okay, writing in factored form, I notice that all these are divisible by 2. Let's start out by factoring out of 2 to make this a little bit easier to work with. That would give me x squared minus 4x and then plus 4. That's interesting, because to me, I happen to notice that does look like a perfect square to me. Just to confirm, a times c is 4, b is negative 4, and when we do that, the things that work would be minus 2 and minus 2. This is going to factor into 2 out front, x minus 2 times x minus 2, which is just x minus 2 squared. And by golly, that looks like a vertex form equation, and it is. We're only going to have one 0 here, and that's going to be a positive 2. And that's also going to be the vertex, because it's going to be at the point 2, 0. Okay, I'm going to draw my lovely parabola that looks way worse than anything that you could ever possibly draw. I need to see it look something like a U, and, well, that's about as good as we're going to get. Next up, we've got problems that involve the quadratic formula and complex numbers. I'm going to take a look at 2 questions as far as the quad formula side. I've got to predict how many real zeros first via the discriminant, and then I've got to find the actual values for those. So for my first problem, I'm going to start off by writing A is equal to 5, B equals -3, and C equals 2. And for the discriminant, B squared minus 4AC is going to be -3 squared, which is 9, minus 4 times 5 times 2, which is going to be 40. 9 minus 40 is -31. Because -31 is less than 0, I expect there to be no real zeros. All right, let's do this out and find out if that's the case. We got -3 over 2 times 5, which is going to be 3/10 in a minute, plus or minus the square root. We just found that, that's -31, and that's over 2 times 5. Only thing that I can do here is to rewrite this as plus or minus the square root of 31, and divide by 10. Do you see what people are missing out on when they don't listen to these as well as just look at the videos? I know, it's crazy. And yeah, at that point you would have been all done. Okay. Number, it looks like a 10, so I'll assume it's a 10. I can't actually see the very left side of my screen, so that's why I can't read what that number is. Just in case you were confused, we've got A equals 3, B equals -8, and C equals 2. First thing I'm going to do is B squared minus 4AC to make a prediction. In this case, that's going to be -8 squared minus 4 times 3 times 2. 64 minus 24 is going to be 40, which is positive. Therefore, I expect there to be 2 real zeros. Okay, quadratic formula time. -8 over 2 times 3, which is going to be +8 over 6, plus or minus the square root of 40 over 2 times 3. I'm totally fine if you leave this as 40 square rooted over 6. All right, for number 13, the only thing I'm requiring you to do is to rewrite this as a positive square root with an I after it or an I before it, depending on how you want to write that. However, if you'd like to earn yourself a nice clean bonus point, you could go further. I might recognize that 45 is made of some numbers being multiplied together, and I might look for one that is the highest possible perfect square, which in this case would be 9. So square root of 9 times square root of 5 times I. That gives us 3 square roots of 5 and I. For number 14, this is a combined like terms problem because of the minus there. I need to be really careful about that. So we got 3 minus 2, and then plus 1i minus -7i. So that's going to be 1, and then plus 1 minus -7. Plus is going to be plus 8i. Number 15. Let's do some distribution. 3i times 3 is going to be 9i. 3i times -3i is minus 9i squared. I squared is always going to equal negative 1. So I could write this as 9I minus 9 times negative 1, which is the same thing as 9 plus 9I. Number 17. Now we've got some multiplication. We got to do the distribution, but this time we got to double it. 2I times 2I is 4I squared. 2I times minus 1 is minus 2I. 1 times 2I is plus 2I. 1 times negative 1 is minus 1. Oh, those cancel out. That's kind of weird. Also, I squared is negative 1, so this would be 4 times negative 1. And then minus 1, which is negative 5. Crazy. That came out as a number. I wonder if you might see a problem like that on this upcoming spiral. The world may never know, but you will. Now we've got completing the square and circles. In general, you guys are liking this a little bit better than some of the other stuff we've done. So the first thing that I might try to do is to rewrite this in vertex form by trying to make this a perfect square. So we got x squared plus 6x plus something. If I divide 6 by 2, I get 3. And 3 squared, I get 9. This has to be a 9 here. The way I do that is I'm going to add 2 to both sides. I'm going to zoom in so I can actually see and write in somewhat of a reasonable way. So that's going to change this to y plus 2 is equal to x squared plus 6x plus 9, which is going to factor into x plus 3 squared. Get a minus 2 to both sides and get y is equal to x plus 3 squared minus 2. That's going to have a vertex at negative 3, negative 2. Negative 3, negative 2. And a slope of 1 on both sides. And hopefully you actually hit your points. For number B, if you need another example of this, we're going to do the same thing. Y is equal to x squared minus 10x, and then plus something. That plus something has to be 25. 10 divided by 2 is 5. 5 squared gives you 25, which means I've got a minus 3 from both sides. Y minus 3 is equal to x squared minus 10x plus 25, which is the same as x minus 5 squared. If I add 3 to both sides, we get x minus 5 squared and plus 3. Okay, going to graph that. Let's have a vertex at 5, 3. And going up 1 on both sides gives me a beautiful parabola. All right. I think I'm only going to do one of the circle ones as a video, so I'm going to cross that out because both of them are pretty much the same. The center here is going to be at 3, negative 5. So that's going to look something like this. A radius of 1 is going to be, because that's 1 squared is equal to r squared. So r is 1. So I'm literally just making like a tiny target, and I'm done. On to the new section. Now we've got systems of equations. We got a few videos to go through, and then some word problems to talk about too. First off, I've got y equals negative 2x plus 5, and 5x plus 2y is equal to 17. I noticed that I've got a y by itself, so it might make sense to me to do substitution. It actually doesn't matter what method that you use as long as you choose something to do this for. So we got 5x plus 2 instead of y. I'm going to do negative 2x plus 5, and that's equal to 17. So 5x plus 2 times negative 2x is going to be minus 4x, and 2 times 5 is going to be plus 10, and that's still equal to 17. I'll move the 10 over to get us down to 7. 5x minus 4x is going to be 1x. Oh, we just finished solving that. Plugging that into my first equation, we got y is equal to negative 2 times 7, and then plus 5. Negative 2 times 7 is negative 14, plus 5 is negative 9. So we've got the point 7 comma negative 9 is our final value. You could also talk about this as x is equal to 7, y is equal to negative 9. You need one of these two things so I can clearly see where your answers are. Number 21. This one also doesn't look too bad to do as far as one from the perspective of substitution, because you already got a y by itself. So I might just plug this in. 2 times 6x minus 7, and then minus 12x is equal to 24. Do some distribution, we get 12x minus 14 minus 12x is equal to 24. I lost an x there. 12x minus 12x is 0, so we get negative 14 is equal to 24. And oh noes, this would be no solution. This is a false statement. For number 22, this one is not set up well for substitution, so let's do some elimination. My goal is going to be to make some of these coefficients the same. I'm going to do this two different ways just so we can see what's going on. But the first, I noticed that to get from 2 to negative 4, I can multiply the whole top by 2. And when we do that, we get 4x, and then plus 6y is equal to 26. When I now add these equations together, we get 0 plus y is equal to 5, which means y is 5. When I plug this back in, I'm going to just use the first one because there's no negatives. 2x, 3 times y is 15, is equal to 13. If I minus 15, I get 2x equals negative 2, which means x is negative 1. But what might happen, you say, if we instead went after the y's at the beginning? So you saw that you could get 2x plus 3y equals 13. And I don't know, I put an underline under that. Negative 4x minus 5y equals negative 21. And if I multiply the top by 5 and the bottom by 3, we're going to get to something that's useful, because we're going to have 10x, and then 5 times 3y is 15y. That's going to be equal to 65. 3 times negative 4 is negative 12x. 3 times negative 5y is going to be minus 20y. And 3 times negative 21 is going to be negative 63. Wow, apparently 3 times 5 is now 20 instead of 15. Woo! So we've got negative 2x, we've got 0, which is what we want, and we've got negative positive 2, which means that x is negative 1, which is the same thing we got going for the other variable. Crazy! And finally, we've got two things that are both equal to y. I might just set them equal to each other, so that would be 2x squared is equal to 3x plus 5. I know with an x squared, I've got to bring everything over to the same side. I tend to like keeping the x squared positive. So we're going to have 2x squared minus 3x minus 5, to minus those both to that side, is equal to 0. And by golly, that looks factorable. A times c is going to be negative 10. B is going to be negative 3. Things that multiply to negative 10 are negative 5 and 2. that also add up to negative 3. So that gives us 2x squared minus 5x plus 2x minus 5 is equal to 0. We got x times 2x minus 5, and then plus 1 because nothing has in common. 2x minus 5 is equal to 0. That gives us x plus 1, and 2x minus 5 is equal to 0, which means x is negative 1, and x is going to be 5 over 2. We've got to plug both of these back in to get y. I might use the first equation because it's less awful. That's 3 times negative 1 plus 5, which is y is equal to 2. And then if I plug this one in, we get y is equal to 3 times 5 over 2 is the same as 2.5, and then plus 5. 3 times 2.5 is going to be 7.5. 7.5 plus 5, we get y is equal to 12.5, or 25 over 2. Okay, let's look at a word problem, and this is going to involve Liam's bookstore, which has 40 notebooks and 40 newspapers for a total of $130. A day later, 8 notebooks and 4 newspapers at the same prices for a total of $28. So we know stuff about how many notebooks were sold and how many newspapers were sold. We don't know the cost of the notebooks, although it doesn't look like it. That's supposed to be a dollar sign. That's even worse. Okay. There we go. And I might call that X. I was going to use N, but then I realized that newspapers is also N, and that's not a good idea. And then we also don't know the dollar sign. Wow, that's awesome words. We also don't know the amount that the newspaper costs, although we know how many of each were sold, and we know the total that things cost. I know that if I want to find out how much Liam charges for notebooks and newspapers, I probably need to make some equations for this. The nice thing about equations in problems like this is that sometimes they're kind of built for us. We know that in general, the total for the notebooks, I'm just going to call that total X, plus the total for the newspapers, I'm going to call that the total Y, is equal to the overall total. I'm going to just call that capital letter total, and if I can fit the L, that'll be perfect. I love it. And I, of course, forgot my X as I was writing that. Okay. For the total of X, it's going to be the number of notebooks. So in the first case, that would be like 40 times however much they cost, which is X. The total newspapers, which would be I sold 20 of them, or Liam sold 20 of them. Total number is Y, and the total is $130. I find it really helpful to begin one of these problems by writing equations in words and then translating that into math. That makes it a little bit easier to see what's going on. Okay, so we've got first equation, 40x plus 20y is equal to $130. We also have 8 and 4 for 28. 8x plus 4y is equal to $28. Okay, this looks like a really good example of a problem that we can use elimination for. And the way I might do that is to maybe try to get 8 to be the same as 40. And I'm going to make it negative so that I don't have to deal with subtracting. I'm going to multiply 8 by negative 5. And that gives me the equation negative 40x minus 20y, and then 28 times 5, that's going to be 140, and that's going to be negative 140. All right, I can already see this problem's going to have some issues. So we got 40x plus 20y, and that's equal to 130. And when I add these together, I get 0 is equal to negative 10, which means that there's no possible solution to this. One of the ways that we could have no solution is if I copy the problem wrong. I happened to steal this problem from Khan Academy because I figured it'd be nice to do some of the ones that you might see for homework as part of the review. Or if this was meant to be this way, let's think about a situation that would result in something like this going on. If Liam's bookstore sold things in these quantities and had got these prices, something funny is going on, and it could be that on the first day, Liam typed something wrong in the cash register and didn't charge enough money, because clearly these values did not come out the same. Hopefully, on the problems that you have on a spiral where I'm really asking you to interpret things, you won't end up with something like this. And just because this happened, let's talk about 27 also. I wasn't planning on this. But here we've got Fiona's Fashion Store, and we've got buttoned uniforms. So a collection of 36 shirts and 42 jackets. So this looks like this is the same type of equation. Contains 842 buttons, and 6 shirts and 7 jackets contains 137 buttons. Okay, so we know there are lots of buttons. I don't know how many buttons are on these different types of things. So maybe buttons on shirts, and that could be X, and maybe buttons on jackets could be Y. Alright, I can't spell things today very quickly, and there's my Y. Okay, so looking at what we got here. So if we're looking at maybe shirt times the number of buttons plus jackets times the number of buttons is equal to the total buttons. I know I didn't write that one down, but I think we might be okay if I just jump straight to this. So 36, we said that shirts was X, and 42, we said that jackets was Y, is equal to 842. Those are really big numbers. Okay. Then we've got 6 shirts, which is going to be X, plus 7 jackets, which is going to be Y, and that's equal to 137. I'm going to apologize in advance because this is not going to go the way that we want it to. This is what I get for choosing problems without doing them on paper before selecting them. I know this looks like another really good candidate for elimination. And if I multiply the bottom one by 6 to get X to 36, and let's make that negative 6, we're going to get negative 36X minus 42Y. And I just did this on a calculator, and that comes out to negative 822. And you might notice, gee, Mr. Carlson, this looks an awful lot like the problem we had in the first thing, which the variables canceled out. I wonder if that's going to happen again, and you would be totally right. Because when I add these together, we get 0, 0, and positive 20. This is yet another no solution problem. We have another piece of an issue here. So this could be that the number of buttons are not actually the same, even though they're sold to us that way. Or it could be that we miscounted when we were trying to do things. Or maybe Fiona's Fashion Store is not renowned for the right reasons. The other problem is, I'm pretty sure I chose the last word problem specifically to have no solution to have this discussion, but it would have been really nice if I had looked at these first two ahead of time. So, have fun.